5 times 5 is?
25.
Yeah. Hey folks, welcome, and welcome out there. It's Mathline time, and you are at the right place, the right time, all sorts of good things. I'm Ernie Robertson. I'm in the right place at the right time. We really have a great show today. We want you to give us some phone calls at 844-686-2378. Make the show rock like we usually have it rocking. And also, give us calls toward the front end. We're getting kind of toward the end each time, like people, oh, we just found you or something like that, and that's great. We want you to call us anytime during the show. But be sure to give so we can get you as much on the air as possible, all right? So go ahead and get lined up. We're going to have a problem of the day here in just a second. But again, that number, 844-686-2378. You say, well, I'm just tuning in, Ernie. What in the world are we doing? Because I've never been to this show before. Well, I'm glad you found us for the first time here, or if you're finding us for again. Remember, his idea is give us a call, bring a math problem with you to talk to me about. We'll work it out live on the air. It could be a homework type problem. It could be, all sorts of different things. Ages, no limit on that. We do the best we can with all the ages possible. We know we have a wide spectrum of viewers here at Mathline. But right now, let's talk about that problem of the day. Here it is. And we're going to take a little algebra tour today. It's find the standard form of the equation of the line passing through the point. That point is negative 6, 2. That is perpendicular to another line, 3x minus 2y equals 6. That's a mouthful. Let's go ahead and take a look and see what we're going to do with this mouthful of work, all right? We have, first of all, a few things just to make sure we understand. Standard form. First of all, that's not slope-intercept form, but we're going to need the slope-intercept form to work through this problem, guarantee you. And we probably are going to call on the point slope. At least I'm going to. I like that approach to get to the final answer here. Another key word, perpendicular. What do we know about perpendicular lines? Well, if we know the slope of one, we know the slope of the other. They aren't the same. Now, yesterday we had a parallel line situation. The slopes were the same. This time, we got to deal with that slope once we find it. By the way, that's this line that helps us out. So we're playing one thing at a time. I'm trying to give you a lot of ideas that's going on here so you can start thinking with me and start working it at home where you are. But let's start right here with 3x minus 2y equaling to 6. By the way, that's a standard form. That's what we mean by standard form. So we're looking for another equation with a standard form that will match up perpendicular to this one, all right? And it will also, we got another requirement, right? That point right there is important because whatever we come up with has to satisfy for the point negative 6 and 2 for your x and y. Whew, that's a lot of stuff to worry about, isn't it? So let's just take it like that, one thing at a time. First of all, let's find a slope. That's the big thing that's missing here. We've got to have a slope, and then we can start working that perpendicular business through and through. So we'll get rid of it. We'll do whatever we want to do, all right? We're going to move that 3x over. Got to subtract it because I want y by itself. That's where we're going. Try to find that slope-intercept form first of all. Negative 2y, you got it. And, I did something that probably it's not a big deal. Everyone knows, right? You can't say 6 minus 3 here. Got it? Because that has not got an x. But just to make sure we're in good shape on that, put that minus 3x plus 6. They are not like terms. Leave them separated, my friends. Leave them separated out there. Got it? Got it? Got it? Yes, you do. Now, let's do a little division moment here. Actually, let's do 3 times on it. Let's divide by negative 2 all the way through. And that's going to give us something that looks like y equaling 3 halves x minus 3. Now, the minus 3 is nice. We got that. But what's most important is this slope. That's what we want to take away from this equation right now. Because this slope is, let's see, we've got m equaling to 3 halves. That's for this equation. But we want the slope of the line that is perpendicular. By the way, that's that little upside down t, symbol for perpendicular. Well, this becomes a little blobbier every time, doesn't it? There we go. It is an upside down t. That is going to be what? Got it? Remember? Think about it. The opposite reciprocal. Opposite means we change signs. Since this is positive, we're going negative. And the reciprocal means we're going to exactly interchange our numerator and denominator. We're going to make the reciprocal. So we got a negative 2/3. That's what's going to be what we need to work with. That's the slope we're worried about. This helped us, got us where we were going. So we've really taken care of the perpendicular part right there. Now it's time to find this equation. So we kind of worked backwards. We started here with the standard form. We got a slope. Now we're going to get this equation based on the fact it's got to pass through this point, negative 6, 2. So this is going to become our x1, y1 moment here when we put it in the point-slope formula. And the point-slope formula says, very simply, if you take the y's with the subtraction, unfortunately we only have one, so we'll put the minus y1 there, equals to the slope times x minus your first x. Well, the only x we've got, all right? So at this time, it's putting in numbers. We don't know y, we don't know x, but that's the whole point. We want to leave them open. We want to leave them open in the end. But we do know that we can put y minus, how about it, 2, equals to, what did I just do? I just replaced the first y with, guess what? Y1 up here. It's the 2. So these are coming down here. Let me put them right there so we don't forget them. It's a negative 6 and 2. All right, so we're going to bring them right down in here. The slope we bring right up from here, negative 2/3, because we're talking about the perpendicular line. That's what we're working with, not a parallel, not the line we started. We are now talking about our perpendicular line. And let's flip out here a little bit. We're going to have what? X minus, it looks like, you see what I see? I'm seeing minus a negative 6 right there. Okay, everybody good? And by the way, what happens when we do it? We go plus the positive, all right, because we add the opposite there. So here we have it. We've got y minus 2 equaling, looks like, a negative 2/3 times x, which is good. Now, what's going to happen when we take a negative 2/3 times, 6? We got to distribute. In other words, we're taking and playing the distributive game here, which is going to give us a negative, right? It's going to give us a minus, so we got a minus 2/3 x. Now we're going to say 2/3 of 6, which is 4, but remember, it's a negative, that's a positive, which is going to give us a minus 4 there. So at this point, we've done the hard part. We have taken 2/3 of 6, and that was the hard part, really. Now we need to get y by itself for this point. All right, we're going to say y equals to, what are we going to do? We're going to add 2, and that's going to give us y equals negative 2/3 x minus 2. And everybody says, oh, are we done? Almost. We have slope-intercept form. We got to get to the standard. Got to get to standard form. Now let's refresh our memory. What does standard form consist of? It consists of no fractions. Well, doggone, we got a 2/3. That's bad news. All right, so we got to take care of that. It also consists of the fact that x and y have to get together. Well, we've got to move that negative 2/3 to the left. It's positive 2/3 x. All right, it's got to go over there. And then, well, that number looks like it's going to be happy over there, but it may change. Got to watch out. All right. So let's see what we're going to do. First of all, we're going to clean up this fraction. To do that, we multiply through it by the common denominator, which in this case is going to be 3. We'll take 3 through everything. The beauty of it, it loses the 3, but the other part of it, the other beauty of it is it's going to make 3y happen. Be sure you've kept 3y. Don't leave it out. Equals, keep going here with me. Looks like the 3's are going to disappear, which is what we wanted. So we got negative 2x. And it looks like minus 6 carrying away here. All right? So far, so good. I think that looks pretty good. Now, where are we going to go with this thing? We are going to move this 2x over because it says what? They get to come together. And good news, when we move that negative 2x over, we are positive. So we don't have to worry about any signs. So I'm going to shift it to the left. It's going to be 2x plus 3y equaling to negative 6. And at this point, to make sure that we are on the right track, we want to make sure that this actually solved out. It looks good. It's standard form. We got x and y together. The truth is, does negative 6 and 2 work in there? So we put a negative 6 in for x. That gives me what? 2 times negative 6, negative 12. We have 3 times 2, which gives me positive 6. Add negative 6 and positive 6, you get that negative 6 back. That, folks, tells me that we have a good equation. And that is the perpendicular in standard form. That was quite the problem of the day, wasn't it? So there we have it. Got it worked out. We did check it through. For those of you who are wanting to go further, you can always go back to these slope-intercept forms, check them with your graphing calculator, get the y equals on there, show that they make a right angle together, and on top of that, that you will come up with the point -6 and 2, when you trace it, it'll be on your line, the perpendicular line. It will not be on your first line, probably, in all reality. Absolutely not. Will not fit there. So, again, it's all about the second line. So there you go. Problem of the day solved. And let's work on some good old callers getting to me, all right? That number is 844-686-2378. Now, I want to pick up, and while we're waiting for some callers, and hopefully we'll get some, we've had them the last few days, and like I said, a lot of times they wait till the very end, and then we just don't have much time left. So let's take a look at where we left yesterday, all right? Taking off, let me pull it back down here a little bit, because we got started. We did not get this far. This was where we basically, actually where we ended up was right here on the show yesterday. But here was the problem, and we're going to come back and we're going to regroup, because some of you are going like, whoa, there's all sorts of stuff there. And it's all like, looks like gibberish, I guess, yeah. So we're going to work with it. But the gist of the problem was we had a rectangular swimming pool that was 24 by 16. She gave me the units, all right? It was from Ashley. Ashley, if you'd like to call back again, you're more than welcome. We'll talk it through the rest of the end of it here. We had also, that allowed us to figure out the area in square feet of the surface area of this rectangular swimming pool. Now, they put a walk around here, a walk of even width. So in other words, the same amount of feet, although my picture doesn't quite look like it. That's what happens when you do freehand. And today's looks a little bit better. We're going to redraw this figure for you. But the idea is you have an extension here, some dimension. You don't know what it is. We'll call it X. You have a dimension out here. We'll call it X. But you've also got to go back this way, call it X. And this way, call it X. All right? So, and oh, one other thing she said. The area of the pool equals the surface area of the patio, which tells me that all this space that's surrounding it in square footage is also 384. So what we did, in fact, let's just go back to see what we did, all right? Can we take it away just a second, guys? Let me bring a new and improved looking picture, I think, here. Let's go back to the infamous rectangular swimming pool with the surrounding patio question. Here we go. Oh, it looks a lot brighter, doesn't it? Now, what we need to do is figure out what are our dimensions here. And remember what I said. 16 was from here to here. But we need to get to the outside, because what's going to happen here is if we could add the area of the pool inside here and then this area of the walk out here, we should have doubled our square footage. So that's what I'm doing here. That's where I get the 768. We'll get it right. Is because that is what we do when we double or when we add 384 plus 384. That gives us this square footage. So for those of you who are wondering where that popped up from yesterday, we were at a rush. We were trying to do this thing in about 4 minutes, and we really needed 10. So we'll try to pick up again for it today, and Ashley, I hope you're tuned in. Here, going across through here, let's talk about what the width of the outer rectangle is. Because, folks, that's what we're doing now. We're looking at the whole big rectangle pieced together. And if we can get dimensions established here, guess what? It's length times width again. So here we go. We have an X going this way. We have an X going here, which means my length up here is now become 24 plus, yes, you got it, 2X. There we go. Now you say, Ernie, why are you going through this approach? Well, this approach was what Ashley asked for. We said we also needed to use trinomials, all right? We don't have a trinomial yet here, but we are going to have one to factor here in just a second. These are two binomials that are going to FOIL out and give us a trinomial, okay? So patience out there, my viewers. Patience and watching along with me here. Going in the vertical fashion here, our width had 16, but we added an X to the top, and we also added an X to the bottom. So our dimensions now on the outside are 16 plus 2X. Now, friends, it's a rectangle, so this side is also 16 plus 2X, if you want to put it there just to keep yourself happy. It's not a perimeter problem. I'm sorry. It's an area, isn't it? So all we really need is a length times the width, and that's what we have set up. So far, so good? Nod with me. Some of you are going like, whoa! But others of you are going like, I think I got it, all right? We're looking at a big rectangle. The big area is twice this size, okay? Now, it's time to do that good old Algebra 1 pre-algebra trick called foiling. Multiplying your binomials together. And this one, the numbers are pretty, they're not pretty, okay? We'll just be simple about it. But we do know already that when we take 24 times 16, we do get that, goodness, that 300 what? 84. So there it is. We're just going to FOIL. That's first. Go to the outer. Go all the way out there. That's going to be 48x. Come back to the inner. 2 times 16. 2 times 16, there we go, is going to give us, not equals yet. Nope, we're not ready to equals. We're ready to put a plus there, my friends. Plus 32x. And last but not least, we got to get those. That's going to be 4x squared. And some of you go, oh, we know how to deal with those x's. Those x squareds we don't like as much. And it all equals to what? 768. So we're going to make this thing prettier, all right? Because it's just kind of nasty right now. It really is. So we're going to go ahead and add that 48 and 32, which we did just barely at the end of the show yesterday. And some of you are probably going, where'd you get that 80? Now we're going to show you. We have 80x plus 4x squared equals still 768. All we did was combine like terms. Now, if I'm going to factor, which is what the whole point of the problem was, I think from Ashley's standpoint, we said we want to have a trinomial and we want to find the solution for factoring a trinomial. So we're going to move the 768 to the left. And what happens there? Well, you know what happens there. It's half of 384, isn't it? So we're going to end up with a negative 384. We're going to come up with a 0 here, but we're going to subtract, all right? And to make life easier, let's do a little commutative property moment here. Let's put 4x squared to the front. Keep 80x in the middle. But what happens when I subtract 768 from 384? Those of you who want to see it, let's do it. Let's calculate real quick here. 384, and we're going to subtract 768. Ashley, I hope you're watching this, because this is really a great problem that she gave us yesterday. And we have now minus 384. Well, how about that? Did we expect that? I don't know that I expected it when I started working through the problem, that we'd end up with a 384 back again here. They seem to be popping up everywhere, don't they? But let's do this. Let's do this, because that's nasty. Those are big numbers. Let's divide everything through by 4, because 4 will divide into each of these numbers evenly. You say, wow, Ernie, you're right. Of course I am. That's why we're working the problem together, right? So, of course, we got it here. X squared plus 20x. I'm just kidding, y'all. It's not always that I'm perfectly right. But in this case, it does work, because I see an 84. I know my divisibility rules. And we're going to divide. Woo, what is that going to give us? I know it's going to work. So let's go ahead and divide by 4. And I see minus 96, which is what I wanted to see. Because now we're at a point where we can break this thing down and factor. You're at a good point right here. And I believe what Ashley's question was, what is the actual width of the walk? And we're about to come to that. All right, so those of you who've been patient and waiting here, those of you are kind of going, I wonder where this is going. Hang with us. We're going to take that x squared, I'm going to rewrite it up here, plus 20x minus 96 equals 0. That's still not the prettiest number to factor, Ashley. I'll give you that, okay? But there is a way to factor it and come up with 20 in the middle. Now remember, my friends, we've got x plus and x minus. And these numbers are 20 apart from each other. That's what that 20 in the middle is telling me. And that number there has got to be 20 more than the number going in here. So I start thinking of, how do I multiply to get 96? Well, you could do 2 times 48. That doesn't fly. How about a 4 divided in there? Now, I'm going with smaller numbers. You know that. You notice that. 4 and 24 are going to work. Oh, why not? Let's put the 24 there and the 4 right here. And you know what? We have it to where we get a positive 20 back in. Again, mental math or FOIL it out. Got x times x is x squared. You knew that. 24 times 4, we knew that. It's going to give us 96. It's a negative. Now, the big check is, do we have positive 24 and negative 4? Yes, we got it back in the center. So were we done? Almost. We've got 2 options now. X could equal negative 24, because remember, we're trying to get these parentheses to equal 0. So we could have x equals negative 24, or we could have x equaling to 4. I like x equals 4 because I'm not seeing many negative links or pools or whatever there. This one is what we're looking at. So right now, we all think, because it really worked out nicely, that number is 4 that goes right in here. If there's a 4 here and a 4 here, you know what? That means I'm basically adding 8 to the 24. I'm adding 16 and 8 to get 24 here. This, by the way, is going to give me 32. The question is, we're all wanting to know, will we get 768 back out of that? So let's take those new dimensions, 24 times our 32. Again, trusty calculator is good for us on this one. 768. Ding, 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 ding. We win. Ashley, you got it. There is your answer. That width has to be 4 in order to make the area, when we put them all together, to be double what we had originally. So, great question, great problem, and just unfortunately, it took a little more than 4 minutes to solve yesterday. So, but there's where it ends up. I hope you're watching. If she's not counting. Someone tell Ashley your problem got worked out completely. Now you're hopefully ready to take it to school tomorrow. And that's kind of how we do it over here, folks. Sometimes they call us in, and sometimes we create, but this was one that, wow, was brought in, and it's a very, very intriguing problem. Let's go to one more intriguing problem, our problem of the week. We have alluded to this, and, we've got a cylindrical glass with height of 15 centimeters, radius of 4 centimeters. So I'm looking at a glass that's in a cylinder, which like a drinking glass kind of thing. Doesn't have any funny shape. It's pretty much straight up and down. And it's poured into a rectangular pan, just like you'd use a baking pan type thing. Now, yesterday we set up some of the pieces, and we start off just, let's organize. We've got a cylinder, we've got a pan, or a glass if you want to call it that, all right? But we are going to use the fact that we have important information. We have the height is 15 centimeters. We have the radius equal to 4 centimeters. That's important because that's going to help us find volume. This is all about volume, by the way. The pan is going to have 3 numbers associated with it. It really doesn't matter, but how about it? We'll let the length be 5 centimeters. Don't know how they really came out. We got 3 dimensions. They work together. We've got a width at 15 centimeters. And then we have a height, we'll say, of 10 centimeters. Everybody good on that? So in looking at that, and yesterday we talked about the formulas. Today, well, let's see what they are. I'm going to put it right down the middle here because I have a feeling these are not going to be the same this time. I know some of you say, is this one of those trick problems you have, Ernie, where they both come out to be the same? Well, the question is, will the pan overflow? We decide, okay? We'll check and see. Maybe it will, maybe it won't. The formulas, here we go. We said the volume for the cylinder is the base area, which, by the way, is a circle times the height, okay? So we're going to go one step further here. The base area, that would be pi r squared times h. Now, dear friends, at this point, you've got h, you've got r. You can attach pi and punch it in the calculator and see what 3.114, blah, 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 on and on gives you, all right? And then round it off to something that will come comparable to this, all right? That's your option how to round off. Now, let's see what's going on, because these are going to come out pretty nice. So what's going to happen here, the volume is equal to, you got it, length times width times the height. So simple deal. It's that easy. Just multiply the 3 digits, 3 numbers here that we've got. And you know what? Remember, you're in cubic centimeters for your volume. That's your hint. That gets you one step closer. And tomorrow we'll reveal which of the 2 pieces is larger than the other. I think at this point, most all of you can go to your calculator, go to a little arithmetic world, and you can fill in the details, because now it's just substitution. Just substitution and simplification. And then compare. And the eyes will tell you everything you need to know at that point. So you've got it going. Everybody good on that? And those of you on Facebook, keep plugging with me, okay, on that. It's also on the Facebook there, so I know a lot of folks are taking care of that. Now, we're going to do some interesting things this week with Mathline, or actually next week, because Monday is President's Day, and we'll be taking a little hiatus. Most of our students are out of school in celebration in honor of the President's Day. And we're going to do a little bit of fun with the President's ages at inauguration. And tune in there. I think you're going to find it very interesting. If you work with graphing calculators, teachers, and students, Get those handy, have those looking, because we're going to use those to refer. We're going to be painting some pictures on there, drawing some pictures that sometimes you don't get to do in class, all right? So take a look at that. That's Monday during our time slot here. Again, we will be live tomorrow, one more time with live, and Friday we have some sort of special slide segment coming your way. Probably be dealing with some of those great old surface areas like we had this past Friday, all right? Don't hold me to that yet, but I think that's where we're headed, all right? But thank you for tuning in today. Remember, you can check us out on Facebook. You can check us out on YouTube, all those great things. We really want you to share us off Facebook. And on YouTube, subscribe and check out some of our videos that we're posting. And we're going to work some of those too to try to get them even into smaller segments that are more usable to each of you guys. That's coming in this year. And again, thanks for tuning in today. Didn't have any calls in, but we've had some good calls this week so far. We hope for some more tomorrow. And in the meantime, again, thanks for being with us, and we will see you again next time.